The stars are the one who created everything we know across the universe. We know how they are born and die tragically, with a huge explosion. But to take a new birth, the afterlife, and becoming more powerful than they were. Death of the stars. The black holes.
Since their discovery, the black holes has grabbed the attention of many people, due to their invisibility and mysterious nature. They are considered as most powerful objects in the universe. But how these objects are formed? And what are they?
Formation of the black holes.
When a massive star, of mass 1.5 solar mass, or more dies, it explodes into a supernova, releasing its outer layers, and its core collapses on its own gravity and results a black hole.
Formation of the black hole depends on mass of dying star, as classified by Chandrasekhar limit, which is 1.4 solar masses. So stars with the mass lower than this dies and forms a white dwarf star. But stars whose mass is higher than this, like its mass is 1.5 or more solar masses, then it collapses and forms neutron stars. Or if its mass is much higher, so it forms black hole. As you can see in this chart, if the mass increases, the mass of black hole also increases. How massive the star? Massive the black hole will be, or a remnant formed after the death of star. First we see neutron star, which is 1.5 to up to 2.5, and then later on from 5 solar masses to billions of solar masses. There we can see supermassive black holes, intermediate black holes, or stellar black holes, which are lowest of mass.
But black holes are not holes in space. And they aren't black. So what are they?
Since black holes have very high mass, so due to their high mass, they have very strong gravity. But it's so strong that it bends space-time very complicated manner, so that even light particles, the photons, can't escape it, because its speed is 3 billion meters per second. So escape velocity for black hole would be more than this. So nothing can escape from black hole. So this is the reason why they don't emit light, because light can't escape it. So that's why they seems to be black in black space.
The discovery of black holes is credited to a German physicist and astronomer, Karl Schwarzschild. He first derived the exact solutions of Einstein's field equation of general relativity. He showed that some objects with very strong gravitational pull can stop light, and derived an equation called Schwarzschild radius, which is size of event horizon of a non-rotating black hole. What does a black hole looks? Is it a hole or something else? What is the structure of a black hole?
As black holes are collapsed cores of stars, so they are, due to the collapsion, they have become extremely dense and compressed. So now mass is increased so much that it's going down in space-time and warps it, and this the collapsed core has now become singularity. So this singularity is commonly known as black hole singularity. So this singularity is believed to be the end of black hole. But we know that space is four-dimensional and black holes are like hole in the three dimension. Fourth dimension is time, which is not physical dimension. So a hole which is circular, which is in three-dimensional space, is spherical. So we can conclude that black holes are spherical in shape. So we know that spheres don't have any end. So once we enter a one-sided black hole, we will be out from another side.
As per structural classification, a black hole has following major parts. Singularity, center of a black hole, event horizon, it is the boundary of a black hole, photon sphere, outer layer of photons swirling around. An ergosphere, it is also known as acceleration disk, it is a huge disk of matter swirling around the black hole. This is how a black hole looks like.
A detailed infographics of black hole by the European Southern Observatory. Image link in description. A theory given by Sir Stephen Hawking suggests that black holes are black bodies, thus they emit black body radiation, which is called Hawking's radiation. Due to continuous emission of radiation, they lose their mass and energy as per the basics of thermodynamics. So they would eventually evaporate and vanish. If they don't get energy. So how they survive?
So in order to survive, black holes feed on all matter and stars around them, and increases its mass. This is the reason why these objects are considered as most powerful, but dangerous objects of the universe. They are the big monsters of space who feed on worlds, and grow bigger and powerful.
We know that black holes don't emit light or radiation, so how scientists find them? Black holes are very massive bodies, thus they have very strong gravity. Due to this, it pulls matter or stars around it, and sucks its gases, which forms an acceleration disk around them, which swirls around it, nearly at speed of light. The gases in the disk gets excited, and release X-rays and relativistic jets. And these jets are very bright and gets detected. In terms of mass, there are three types of black holes across the universe. 1. Stellar mass black holes, formed by death of stars and are of 5 to 100 solar mass. 2. Intermediate mass black holes. This kind of black holes are recently confirmed by scientists, but not yet observed. They are of 100 to few billions of solar masses. 3. Supermassive black holes. They are the biggest kind of black holes. They are more massive than 10 billion solar masses. They are generally found in center of galaxies. These black holes are formed by the collision of two massive black holes.
What happens if you fell into a black hole? Spaghettification. If we try to enter a black hole, we will face a phenomenon called spaghettification, which is stretching of whole body due to gravitational pull of black hole. But till now we don't have technology through which we can reach and survive a journey to a black hole. There are many theses about what will happen inside a black hole, but nothing explains clearly. We need new theories and laws to understand what happens inside a black hole.
Neutron stars.
When a massive star explodes into a supernova, it collapses under its gravity. It forms a compact remnant called neutron star.
When a massive star undergoes gravitational collapse, its proton and electrons scrunch and leaving behind world's wonderful creation of universe, the neutron stars. They are entirely made up of subatomic particles called neutrons. They are roughly of size 10 to 20 km in diameter, but their mass is about 1.5 to 2.5 times of mass of our sun. Even a teaspoonful of their matter would weigh 10 billion tons.
Some neutron stars have jets of material streaming out of them at nearly the speed of light. As these beams span past Earth, they flash like the bulb of a lighthouse. Scientists call them pulsars after their pulsing appearance. Normal pulsars spin between 0.1 and 60 times per second, while millisecond pulsars can result as much as 700 times per second. By 2010, approximately 1,800 pulsars had been identified through radio detection, with another 70 found by gamma rays. Some pulsars even have planets orbiting them, and some may turn into planets. Scientists recently discovered that neutron stars or pulsars can have acceleration disk around them as black holes. Since gravity of a neutron star is 2 billion times more than Earth's gravity, they can attract some stars and feed on them. If they feed more than their mass, they may turn into black holes.
Like normal stars, two neutron stars can orbit one another. If they are close enough, they can even spiral inwards to their doom in an intense phenomenon known as a kilonova. The collision of two neutron stars made waves heard round the world in 2017, when researchers detected gravitational waves and light coming from the same cosmic smash-up. The research also provided the first solid evidence that neutron star collisions are the source of much of the universe's gold, platinum and other heavy elements. After the collision, kilonova leads to the formation of black hole.
As promised, we have a bonus for our audience. Warning. Content shown here is hypothetical. Existence of these entities is not proven yet.
Wormhole is a short-living portal, which lasts only a brief minute. It joins two black holes in different location across the universe, or even two different universe or different times.
The theory of wormhole states that matter entering a black hole at one end of a wormhole would exit from another end of wormhole, which is white hole. White holes are another hypothetical object. They are just opposite of black holes. Black hole sucks up matter from the universe, while white hole throws out all the matter the black hole sucks in. But this theory is not believed on basis of thermodynamics, because the white hole will add up order to the universe. So it cannot be possible that white holes can exist.
Well, none of these two objects have ever been observed, nor theoretical existence has been proved. We really need new theories and laws to explain various mysterious phenomenons of the universe.